Namaskar, welcome to the channel Anka Anandaharan, that is extracting happiness from the teaching learning process of mathematics. Happy Akshaya Tritiya to all. Here in this video, some of the problems of Gilbert Strang book are being discussed. Here the purpose is the persons, those who could not understand the problems thoroughly inside the class, or those who require a second time revision of discussion. So they can go through this video so that they can do the rest of the problems of the book comfortably and apply the concepts of linear algebra in their real life problems. So only few questions are being done. The purpose is very local, that is some of the students, those who require special reference or special care for them, this video is being done. Now let us discuss some of the problems. The question is, explain why the given system is singular by finding a combination of the three equations that adds up to 0 equal to 1. Next part of the question is, what value should replace the last 0 on the right hand side to allow the equations to have solutions, and what is one of the solutions? So first part of the question is why this system of equation is singular. Let us observe it. Observe here the left hand side of these three equations. What we are getting? Left hand side of the first equation plus left hand side of the third equation gives rise to the left hand side of second equation. So the augment matrix written here, hence it is singular. So let us verify it through augment matrix. The augment matrix written here is 1 1 equal to 2, 1 2 3 equal to 1, 0 1 2 equal to 0. These are the coefficients. Now observe here, the first row minus second row plus third row gives me a 0 vector, and the right hand side of all these equations, that is 2 minus 1 plus 0 gives me 1. That means if I write in equation form, then first equation minus second equation plus third equation. Here u's are cancelled and this v and this v together gives together give 2v, which can be cancelled by this minus 2v. Similarly, w here, 2w here, totally they add 2 give 3w, here minus 3w. So left hand side each variable is cancelling each other. Finally left hand side is 0. And what about the right hand side? 2 minus 1 plus 0 is giving me 0. So I got this combination which gives me an information that this is a system of equation whose coefficient matrix is singular. At the same time, the value as left hand side is 0 and right hand side is non-zero. The system of equation is not solvable. Hence the system of equation is singular but not solvable. This conclusion we got. Next is, for what value, if we replace this 0 value of third equation in the right hand side, that is this 0 value of third equation in the right hand side, how it should be replaced so that we will get solution. Now observe here, from the augment matrix, this left hand side is a 0 vector and right hand side is non-zero. If this right hand side can be made 0, it will have solution. Now this 0, how I should replace to have a non-zero value? If this 0 is replaced by minus 1, then I will get here 0. Okay, so if this 0 is replaced by minus 1, then this will add to 0. Okay, so let us go for this. So my second question's answer is, if the 0 of right hand side of equation 3 is replaced by minus 1, then it has solution. And if a singular system of equation has solution, that means it has infinitely many solutions. So then the system of equation, when the last 0 is replaced by -1, I will get this new system of equation. So where for every value of w, I will get a solution. So now from the last equation, what I am getting my v? V is equal to -1 minus 2w. And when I will substitute this value of v in the first equation, I will get, what is my u? U is 2 minus v minus w. That is 2 minus of -1. So that is plus 1 plus 2w minus w. That is 3 plus w. So if I consider the vector u is equal vector with u v w as its component, u is equal to 3 plus w, v is equal to -1 minus 2w, and w is equal to w. Then that vector for every value of w will give me a solution of the system of equation. So it is this one. That is clearly, if I can write, that is u v w is equal to, what I can write, 3 plus w minus 1 minus 2w w. This vector is a solution of the system of equation for every value of w. Let us substitute w is equal to 1 to get a particular solution, that is 4 minus 3, 1 is a particular solution of it. Okay, so next we will move to another equation or another question. And here answer is also already typed. So what it is telling, under what condition on y1, y2, y3 do the points 0, y1, 1, y2 and 2, y3 lie on a straight line? So here, if I need 3 points which should lie on a straight line, that means the line joining these 3 points should form, first of all, these 2 points joining. Suppose I have, okay, so now I have point P1, point P2, point P3. So if point P1, so it is, let us assume this is P1, this is P2, this is P3. So if my point P1, P2, P3 lie on one straight line, when it is possible? Only when it is the line joining P1, P2 and the line joining P2, P3. They should have same slope so that they will lie in one straight line. And we know for any straight line having points, endpoints as x1, y1 and x2, y2, the slope formula is y2 minus y1 by x2 minus x1. Substituting these values, the values of x1, x2 here, we get that y2 minus y1 by 1 minus 0 for these first 2 points, and y3 minus y2 by 2 minus 1 from the second 2 points. Finally, the denominator is 1. Denominators of both the form equal to, both the sides are 1. Hence, what we are getting? We are getting from this y2 minus y1 is equal to y3 minus y2. So if I take everything to one side, I will get this equation, that is y1 plus 2y2 is equal plus y3 is equal to 0. Hence, for this condition, these 3 points lie on a straight line. Next question is, the column picture form of a system is this given here. Column picture form is given here. U into 110 plus V multiplied with the vector 1 2 1 and plus W multiplied with the vector 1 3 2 is equal to right hand side vector B. so that the three columns on the left lie in the same plane by expressing the third column as a combination of first two. Okay. Next part of the question is, what are all the solutions of solutions UVW if B is the zero vector? This is the question. So let us write down. Here we can clearly observe that the first vector, second vector and third vector, how they are related? My third vector is equal to 2 into my second vector minus my first vector. Observe here, this vector is equal to this vector into 2 and minus this vector. So how much I am getting here? Observe, this is multiplied with 2, so 2 minus 1, it is 1. 4 minus 1, it is 3. 2 minus 0, it is 2. So I got this. That means my relation is, in place of, if my right hand side vector is 0, then what can I write? Here my every relation, then it will be, it has, because the system of equation is, now the coefficient matrix or system of equation is singular, so it has infinitely many solutions. And how they are related? So that is, for every value of W I will have a solution. As the right hand side is 0, it is just the same as the previous system of equation. In the previous problem also the same columns were there in the left hand side. So here what will be the relation? Just that, substitute W is equal to W. What I am getting? 1 from the coefficient matrix. Okay. So what I am getting? V plus W, 2W is equal to 0. That means what is my V? V is equal to minus 2W. Similarly, from the first equation, U plus V plus W is equal to 0. That implies U is equal to minus V minus W. Let us add it. So minus of minus V, that is 2W minus W, that is equal to W. So what I got, my new vector, solution vector? Solution vector is UVW is equal to W minus 2W and W. So for every value of W, this vector gives me a solution. So I got my solution, all solutions of this system of equation is represented by this set. That is, set of vectors belonging to R cube, where each component, this first component is W, second is minus 2W, third is W, for each W belonging to R. So this is the end of the question. So solution. Now let us discuss another question. What it is telling? Sketch these three lines and decide if the equations are solvable. Here, let us draw. The second part of the question is, what happens if all the right hand sides are 0? Next part is there any non-zero choice of right hand sides that allow the three lines to intersect at the same point? Let us discuss. So each line, this is my L1, this is my L2, and this is my L3. So how to plot it? I will plot any 2 points on the straight line. Okay, then from that, those 2 points, I will join those 2 points and I will get my straight line. So I will put x equal to 0, y is equal to 1, y is equal to 0, x equal to 0, y I will obtain value y here, which is 1. Then I'll put in the y is equal to 0, x equal to 2. So this is one point here, this is a point, and this is a point. So this represents my L1. Similarly, this straight line represents my L2, and this third line is this L3, this line. So now one can observe properly that these three lines do not have any common point. There exists no point which satisfies all the three equations. Hence, this system of equation is not having any solution. No solution exists. First part of the question is whether the system of equations are solvable. The answer is no, it is not solvable. The system is not solvable. As it is not solvable. Then if we will make this right hand side vectors 0, then what will happen? Each straight line here will pass through. So right hand side becomes this is 0, this is 0, this is 0. If it is becoming like this, then what will be the situation? Okay, so in that case, this straight line, this yellow straight line will move, pass through 0 with a straight line parallel to the existing straight line. Okay, similarly, I will get another straight line passing through origin and parallel to this straight line L3, passing through origin parallel to L3. Like this it is not possible. Okay, directly I will just plot it. So what I will get? Parallel to So just I will get this L1 line parallel and passing through origin. How it will be? It will be something like this. Similarly, I'll get another straight line, which is a line just parallel to this L3. It is my L3. So just this x-axis. So the new picture will be something like this. Observe here, when my right hand side vector becomes 0 vector, I have a common point, that is passing through origin. So x is equal to 0, y is equal to 0, z is equal to 0. This 0, 0, 0 point satisfies my all the three equations. Hence, it will form a solution. Now, next part of the question is, here because the right hand side vector b were zeros, that is, what is the equation? In this case, what is the equation? X plus 2y is equal to 0, x minus y is equal to 0, y is equal to 0. So here, because it is a homogeneous system of equation and we got origin, always origin is a solution for any homogeneous system of equation. So here it passes through origin and it has a solution. Next question is it possible to have x plus 2y is equal to something, x minus y is equal to something, and y is equal to something? Whether this right hand side, can I make the right hand side some non-zero choice to get a solution? Yes. If this y is equal to 0, I will change. So what it is, previously it was, this is 2, this is 2, previously it was 1. If this 1 is made 0, then this line y of a first picture, observe here, this line, red line y is equal to 1, that is L3, this line will move to x-axis. It will become x-axis. Hence, it has solutions. So, what we got here? If this line y is equal to 1 is shifted to y is equal to 0, then we are getting a solution of it. Similarly, also we can get, instead of changing this straight line, suppose I will move this straight line, second straight line. Okay, x minus y is equal to 2 straight line. This straight line, instead of here, if I will make it pass through origin, so pass through this point of intersection. Here it is, there is a 2-point intersection. If I will make a straight line parallel to L2 and I will make it pass through this point, then I will also have a solution. So that is one of the choice is here 2 to 0. Another choice is I have not changed this last equation, I have changed the second equation. When what is the coordinate of it? It is x is equal to 0, y is equal to 1. So put here x equal to 0, y is equal to 1. How much we are getting? In that case, this new vector will be 2, x is equal to 0, y is equal to minus 1. So it is minus 1, it is 1. For another choice of right hand side, this also the system of equation will have solution. Likewise, the first equation also can be moved to the point of intersection of other two straight lines. Likewise, there are several combinations which will give us non-zero solutions. So the question was, is there any non-zero choice of right hand side for which the system has solution? Yes. This is a non-zero choice of right hand side where the system of equation is having solution. And what about the solution? It is x is equal to 2 and y is equal to 0. This is the solution. So now for this class we will stop here. Next class we will discuss about elimination method by Gauss or Gauss elimination method. Thank you for your patience listening.